Our electronic maths Brailler is a device designed to aid visually impaired students in learning maths and science. It allows users to easily write, read, and compute in Braille. The device consists of two distinct components: a motorized Braille display with keyboard shown on the right, and a graph display that you can see on the left. The Braille display serves for displaying text and equations in Braille. The mechanism for each line of text consists of 40 3D printed orthogonal discs, containing a different 3-dot combination on each side. Each hollow disc is placed along a metal shaft and held in place by a spring mechanism. A release from the spring and a shaft rotation allow the movement of individual discs and thus a refreshable content. This simple sequential mechanism has one main advantage: it reduces the price of the device. However, this happens at the cost of display speed. The current design contains 4 lines, providing more space for doing complicated maths, while still keeping the price of the device lower than currently available online Braillers. We will now focus on the keyboard. What is displayed is determined by a keyboard and a built-in processor. The keyboard uses the design of standard Braille typewriters for ease of use, and the text written in Braille can be directly displayed or be used as an input when the device is in calculator mode. The maths the calculator can perform range from basic operations such as multiplication, division, and square roots to more complex ones like differentiation and integration. As for the graph display, the graph mode of the keyboard lets the user choose from an equations library and display it on a flip dot display. Each dot has a flat side and a side with a tactile dot. The Arduino was programmed to control which side is on the top and that way display different graphs. The graph display was separated from the motor display in order to provide uniform resolution without line spacing in the graph. Moving on to the user requirements, so far the device mostly meets the important requirements such as functionality, affordability, and level of maths difficulty, which was A-level. However, with increased functionality, the size of the device also increased, making it less portable. The device is also mains powered, and therefore doesn't have an independent battery life. Due to time constraints, we couldn't conclude the project, and thus our list of improvements is long. Areas of future improvements include portability. The perfect balance between functionality and size must be determined. To this end, a removable battery should be incorporated to eliminate the constant mains power dependence and make the device fully portable. Resolution. By replacing the second-hand flip dot array with a custom-made one, we can reduce the size of the graph display and maximize its resolution. Manufacturing. Using tools with higher precision to manufacture the parts of the Braille display will minimize mechanism inaccuracies and improve speed. Interface. The design and the user interface must be improved, and further user testing should be conducted. As well as this, the hard-edged graph display casing should be changed to improve user comfort and safety. Exercises and feedback. The SD card slot and audio output for interactive exercises should be available. In conclusion, despite the limited time frame of the project, our device allows visually impaired users to write, read, compute, and graph in Braille, something not possible with any other Brailler currently on the market. Our team really enjoyed working on this project, and we believe that with time, the full functionality of the device can be achieved. We would like to finish by thanking the people who helped us throughout the year.